All right. Hi. Today's lesson is going to be on Java collections. And we're going to be covering some concepts such as a custom array list, data structure that holds integers and increases in size when needed. We're going to compare that custom array list to the collection interfaces array list data structure, the existing array list in Java. And we're also going to compare it to the map interface Hashmap data structure that also exists in Java. And we're going to do that through Java code examples. And then we're going to have a question and answer section if there's any questions about the lesson. Let's get started. So, what are Java collections and how can they be used? Basically, a Java collection is a container that can hold data in groups and manage that group of data based on the needs of that data structure. So in the case of an array list, it typically has a collection of arrays. A collection of integers. If the data type for the array list is integer, we'll see an example of that in a moment. And sometimes you need to grow the data type that's inside of your data structure. So we'll see an example of an internal array increasing in size inside of a custom array list, just to show you what it looks like, on a small scale compared to the Java systems array list and what it does under the hood. All right, so we're starting off with the Hello Live Lessons, and we're just basically going to run this and show Hello Live Lessons on the right. Perfect. All right, getting into the basics of what we're going to cover today. We basically need an array basic array initialization. Right? And that will look like integer array new int array, and let's create it at size 3. You know what? Let's create it at size 3, but we're going to use the numbers 1, 1, 11, 22, and 33 as the initial values for the basic array. And these values are going to be used over and over in all of the examples that we're going to cover. And the next thing that we want to do, let's say, so basically what we have is an array with the values 11, 22, and 33. And just, to show that this data can be output to the console as is, I'm going to bring in an import from the Java util arrays class, and that is going to allow us to do a print for the arrays, and just to kind of give us a visual update of what's happening with the code. All right, so we have a system out print line, and then we're printing the array, and then we're printing the contents. We're using a method or a function of the arrays class .toString, and basically it takes the array, and then it internally it cycles through each position of the array, and then it prints out the individual values But it also uses brackets on the left hand and the right hand side to kind of indicate that it is an array that's being printed. So I'm going to save this and run it, and then we're going to see an example of an array, what it looks like printed out. All right, so we have 11, 22, and 33. Awesome. So the next thing that we want to do is to increase the size of the array, because, you know, with an array list, with the array list data structure, you basically have to increase the size of the container to allow more data to be added to it. So increasing the size basically looks like creating a new array, taking all the values of the original array, and then assigning it to the new array, and then taking the new array and putting it back inside of the original array. So this is something that we're going to do more than once, but this is just an example to get us started. So basically, we're going to create this new array, new int array of size array.length times 2. So we're going to double the size of the array, the original array here, by taking the original array's length and then multiplying it by 2. And then we have a total of 6. We have a total of 6 after that. All right. So, all right. The next thing we're going to do is, normally we would use a loop to do this part, but because we're not covering loops until 2 lessons from now, I'm going to use just explicit lines of code that reference index 0, index 1, and index 2, because that's what we already have: index 0, index 1, and index 2. All right, so we are going to say new array at index 0 equals array at index 0. So what this does is it copies over this 11 into the new array's first position. And we're going to repeat that for all the other positions. 1 and 2. All right. And lastly, we need to maintain the original array, because in the next example, we're going to do the custom array list. And with the custom array list, we're going to be using one array for all of the operations within that object or within that data structure. So let's go ahead and reassign array, new array. And what this does is basically takes all of the data that was created for the new array, and then it resets from this 11, 22, 33 of size 3 to 11, 22, and 33 of size 6 now, because we just doubled the size of the data that we need. All right. And I believe we want to add one more value. So we're doing all of this just to be able to add one more value to the array, because currently the size is 3. We want the size to be at least 4, so we can add one more value to it. So the next thing that we do is add the new value. All right, so we're going to say array sub 3 equals 44. All right, so basically what happens here is we initialize the array with 11, 22, 33, making it of size 3. and we print that out, 11, 22, 33. And because we want to add one more digit after the 33, the 44 here, we need to increase the size of the array to be able to add the new digit. So we double the size of the array by creating a new array of the double of the array length times 2. And then we go into the new array and we take the values of the old array and we assign it to the new array positions. And then we reset the original array to the new array. And now when we say array sub 3, we'll have 11, 22, 33, 44. And we're going to have a problem. We're going to have way too many values available because we doubled the size of the array. So we'll have a 0 and another 0 after the 44. You'll see that in just a moment. Yeah. So because we doubled the size of the array, it went from size 3 to size 6. And we added the new digit in 44 in the position that we needed it to be. But you know, when we're reporting it to the screen, we're saying too much about the array. So this is where the data structure of ArrayList comes in, because we can actually minimize what we want to see on the screen. We can show up to the index that we're currently dealing with. So in this case, the index that we're currently dealing with is 0, 1, 2, 3. And beyond that, we don't have to show anything else on the screen with the custom data structure. All right, so moving along, let's go ahead and start the creation of the custom array list. Class custom array list. And one of the things that we're going to need for this custom array list is we need to know what position we're adding the new value at. So I'm going to create a current index, and it's going to start at 0, meaning when we add the first value, it's going to add it at the position 0, meaning if we add an 11, it adds it here. But if we add another number, 22, it adds it at the next position, because we're going to increase the current index to 1 and to 2 and so on, so that we know exactly how far we need to go with adding the new position or adding the new value in, and also how far we need to go in printing out, you know, the values that are available to be displayed. Yeah. All right. Also, we're going to create an internal array. And this one is going to be pretty basic, because when we create the custom array list, we're actually going to give it a size in the constructor of that custom array list class. All right, so we're going to start it off with an empty array. So basically, it doesn't have any values at all. All right. And moving along, we can say public custom array list, and we can give the parameter of size here, and we're going to reassign the internal array. Internal array equals new int array of size. All right. And we're also going to need a method called add. And it's going to take a new integer. Right. Now, a couple of things need to happen inside of here. We need to check to see if the current position is allowed. If not, then we need to increase the size when needed. And because we're not doing loops yet, we're also going to have to address that. And then we're going to have to add the new value. So these three things that we did before over here are also going to happen inside of the add. And we also should have something called a toString, which is a method that comes from the object class. If you saw the What is a Java Object lesson, which is on YouTube as well as on our Facebook page, you'll see in that example, I talked about how all classes extend from objects. So because of that, we have access to this toString method here. All right. And basically, I'll show you exactly what the toString method does in just a moment. All right. Okay, so remember with the original array, it printed the brackets and then it printed the numbers in between the brackets. We're going to do something similar to that here. So the integers use the letter D for decimal to print out the values. And because we're only going to go up to 44, we're only going to add one more value position and insert that value. Oh, I'm only going to show 4 here because we're still not dealing with loops yet. All right. All right. So let's just get that out of the way now. Position 0. Oops. All right. So 1, 2, and 3. All right. So this will basically report to the screen exactly like this. Yeah. But yeah, we're going to do 4 digits instead of 3 in this case. All right. So we have the add, and we need to do a similar implementation to what we did here. So increase the size when needed. So we have an if that we need to create here. And we need to say if the current index is greater than or equal to the internal array length, that means that we've come to the end of the internal array and we need to increase the size of the internal array so we can add more items. So what that looks like is basically what we did down here. We create a new array. Let's see. Okay, yeah. Yeah, so we basically create a new array from the internal array. And then we take the internal array values at position 0, 1, and 2. Normally we would use a loop here, but because we're not doing loops until 2 lessons from now, I'm going to explicitly do 0, 1, and 2 here. And then once we're done with assigning the values from the original array into the new array, then we can do the last step down here. All right, so instead of array, this time we're going to use the internal array, and we're going to add it at position 3. And instead of this, we're going to take the new integer here. And one more thing needs to happen. We need to increase the current index. So current index here and current index here. Okay, so we're going to come in here, and whenever we start off, custom array list is going to be of size 3. When we come in, this will be 0 and then size 3. So 3 is greater than or equal to, 0 is greater than or equal to 3. No, that's not true. So we keep going past this, and then we say internal array, current index, add new integer, and that will be the 11. So we put the 11 inside of the first position of the array, and then we increase the current index. So we come and if we call add again, maybe with 22, we're at current index is 1. Is that greater than or equal to 3? No, it's not. So it skips over this, and then it comes here and it adds the 22 at position 1, and it continues on and on until we get to position 3. So once we add the third value, 33, this current index will be 3, and 3 is greater than or equal to 3. So it comes in here, and then it doubles the size from 3 to 6. And then we take all of the first 3 values, and then we reassign the new array to the original internal array. And after that, we add in the new value at position 3, and that new value will most likely be 44. So that's when we get the new position of 44, and then we increase it to move on to the next position. So when we print this out, it'll be 11, 22, 33, and 44 when we print out the custom array list. All right, so let's go ahead and create this custom, an instance of this custom array list. Right, custom array list, CAL equals new custom array list. We need to give it a size, let's say 3. And then we're going to say custom array list dot add, and let's add 11. And it'll be 22 and 33 and 44. So we start off with size 3. And basically, without the growing algorithm or the check for the size algorithm, we would only be able to add 11, 22, and 33. But because we have that check for the size, or what we call the increase the size when needed, we can basically add in the next value of 44. So let's go ahead and print that out. All right, so this would be the custom array list. Instead of arrays.toString, there's actually a toString attached to the custom array list. That's what this guy is here. So we're going to print the brackets, and then we're going to print all 4 of those positions. All right, let me double check. Looks like everything is good. Let's check for errors or test it out. Okay, great. Notice how the custom array list is not going to print the extra positions because we didn't want it to. Like if I wanted to, I could have added position 4 and 5 here, and then it would have shown the 0 and 0. But you know, when we get to the looping, we'll actually go up to what the current index is. So whatever the current index is, we'll stop before we print out any values beyond that. All right. Okay, so we have 11, 22, 33, and 44, and everything's in memory. So I did all of that just to kind of give you a look underneath the hood of what the array list actually does. So let's save us a little bit of time and change this custom array list to an array list. And we're not going to give an initial size for it, but we are going to import it So it comes from the Java util package. If I click import, it brings it in up top here, right? Oh, okay. So one more thing needs to happen. I basically need to make all of this array list. And this won't be custom array list, but it'll just be array list. And you'll notice that it will also print the same way that our custom array list prints, except if this one is dynamic. We haven't made it with for loops, but the system array list from the Java util package actually uses for loops internally to grow all of its data properly. But this is just an example. So let's run that again. And we have array lists with 11, 22, 33, and 44. Awesome. So how this works under the hood, a small glimpse into that would be this implementation of the add method, where we basically increase the size when needed. And we add the values when we don't need to increase the size. We're always adding the values. And once we add the value at the current index, we change the current index to the next position. All right. And lastly, I'm going to cover the Hashmap, which is not an interface, or it doesn't implement the interface of collection from Java, but it does implement the interface of map from Java, which both are data structures. All of the collections are data structures, and all of the maps are data structures. Just to kind of give some insight into how that works. Collection is an interface in Java, and it implements an interface called iterable, which might come in handy later, but a list is a collection, and an array list is a list, which is a collection. There are other types of collections like set and queue and things of that nature, but we also have maps. So maps, generally I use hash maps, but there are different types of maps where it's like a, an enum map, so to speak. So basically, this is the reason why I'm covering a map, because we can also hold similar data inside of a hash map, but we're not tied to using positional data. Like if we store the data in a hash map, it's not always going to come back as 11 in the first position and 22 in the second position and so on. It'll actually reorder them because the hash map is not ordered. All right, so just to kind of give a little bit more insight, the Java docs for collection, some of its children or the classes that implement the collection interface are all of these, but the ones that we dealt with today are the array list, and that's pretty much it from here. At some point, we might implement a data structure for linked lists if people ask for a lesson on that. And moving on to the array list has the interface of collection as one of its parents, so to speak. And basically, in that implementation, there are methods that the collection interface has, like add. Like once you implement the collection interface, you have to have an add method, an add all, clear, contains, and so on. All of these are the methods that deal with the collection interface. So you have to implement them, or you could make your class abstract. So that's why we have abstract collection, abstract list, and all of these, because they didn't implement those methods, but they just passed the responsibility off to the next class that would implement abstract list as a subclass. All right, and moving on to the map. So map it's basically an interface that you have to implement clear and compute and entry set and equals and get, and the put here is the most important method of this example or this lesson, because I'm going to use the put and I'm going to use the toString for it. So also there should be a toString available, but it doesn't come from this interface. It comes from the object. Well, let's see, classes, sub interfaces. Whatever class that you implement with will have the toString as one of its parent methods that's available. So yeah, so that's why we'll be able to see the data for this map. Okay, yeah. So the hash map is an actual object. So it comes from the object class. So it will have the toString available to it. So that's how we'll be able to see the actual values inside. Where is it? Inherited from map object. Okay, from object. Oh, here we go. Abstract map, toString. So yeah, we have a toString that comes from the abstract map. All right. Now let's get to it. So basically what a hash map example with these same numbers would look like would be something like this. Let's see, hash map. And the hash maps have a key. So in this case, let's use a string key. And then the hash map needs a data type for the value. And notice how we use the capital I integer. This is a wrapper class around the integer, similar to how the ArrayList is a wrapper class around an array. Basically a primitive array of integers, or an array of integers of the data type int. And yeah, so when we have this class here, it's actually a class that has a single integer, like just a regular int inside of it, you know, like the regular declaration of an int inside of it. And it adds methods and functionality to it that allows it to be passed around to data structures like the hash map. So, and also the array list. HM hash map string and okay, we're going to import hash map from Java util. And we're going to pretty much do the same thing as this, but instead of the add method, Hashmap has a put method. And the key, in this case, let's go with first, because instead of, you know, just a single digit, we can actually put a word or some kind of phrase or, you know, formatting if we need. And the first one is going to be 11. Okay, and the second is going to be 22, and the third is going to be 33, and the fourth is going to be 44. Now, I didn't do a custom hash map. That data structure is way more complex because you have like a hash table internally where you basically map, you know, whatever the key is, and you have to search through all your keys. And then once you find that key, you can access the data related to that key after you search for it. So that would be a bit more complex. If someone asked for a lesson on that, you know, I would be willing to do it, to do a custom hash map data structure. But yeah, if you have questions about it, please ask. All right. And the last thing I need to do is print the hash map. So this hash map, right? Okay. Okay, so with the hash map, notice that they're not in order, like the array, because the array is generally, ordered position 0 to position 1 to position 2 to position 3, etc. But with the hash map, it's a lookup table, and basically, however the keys just get ordered randomly, we grab those keys, and then we report the values of those keys alongside those keys. So the keys are not in any kind of special order. All right. And let's check for questions. All right. A question. Yeah, someone asked about AutoBoxing. What is AutoBoxing and unboxing? And basically, AutoBoxing and unboxing is what we do with the integer class. So because this is a primitive and this is an object, there needs to be a conversion between the two of these things. And essentially what happens is we're basically auto-boxing the primitive 11 into an object of integer. And we're unboxing whenever we access that, maybe with the printing or something of that nature. So when we say hm.get first, it actually takes the integer object. And you know what? Let's just do an example of that. Let's see, hash map at first. Here, get, and here we're going to say first. So what this is doing is basically accessing the integer object from the hash map using the key of first. And what it does is it takes the integer object and then it converts it back into a toString. But if I wanted to have first variable here of integer type, and basically put this first over here, what happens here is it takes the object of integer and then it unboxes it and converts it back into an integer. So that would be the comparison between AutoBoxing and unboxing. So this part, when we take the primitive and give it to an object reference, it is AutoBoxing. And then when we extract it from some data structure, it comes back as an integer, but it unboxes and converts over to the primitive. So let's go ahead and run this. Yeah, so hash map at first is 11, as you see. So let's go ahead and say unboxing. And okay. Any other questions? Let's see. I have to make a sorted queue. Which Java collection should I use? So there is a data structure called queue. And the queue basically deals with like ordering. No, not ordering. It basically deals with adding data in an order. Yeah. Now, the data itself doesn't have to be ordered, but when we access the data from the queue, we add to the end, but we access from the front. So there's this terminology called first in, first out, where it basically, in the case of this array, if this was a queue, the first item in is 11, and then the next one is 22, 33, 44, and etc. But if it was a queue, to remove an item from this list, we could only remove it from the front. So that's what I mean by the order. But when you have a queue that needs to be when you need to have a queue that already has the order of removing, but you also need to sort that data, there's something called a priority queue. So basically, a priority queue is a data structure that already exists in the Java packages. And essentially, if you just deal with integers by themselves, then it automatically knows how to sort it, you know, and I believe it goes from lowest to highest by default. And if you wanted to do it on objects other than integer, you would need to implement a special kind of interface for that. I think it's called comparable. Let's see if I can find something real quick for that. So let's see, implement comparable. Oops. Oh. Okay, here we go. Yeah, so basically, when you implement the comparable, there's a method called compare to. And the reason why we need this is because we need to know the order of the items that come from the priority queue. So let's see, we have the collection and then we have the queue, which is basically ordered where you can only take from the front, first in, first out. And the priority queue basically implements the queue or extends the queue. And essentially, the priority queue orders the data how you need it to be. So let's go ahead and pull up a priority queue example. Priority queue. Okay, no, this isn't what I need, but no, this isn't what I need. Maybe we should do an offline Q&A because this lesson is coming to about 45 minutes now. Yeah, if you like, please ask the question maybe in a direct message. If you're on Facebook, if you're on YouTube, I'll just double check there and answer the questions in line. But yeah, so basically that kind of concludes our Q&A for now. But there is an example of a priority queue available, but it's not something that I can find, and it wasn't really within the topic that we were covering today. So yes, it's a collection. We were focusing on the array, custom array list, and hash map, just to kind of give a different type of data structure to kind of look at under the hood. But our next lesson is going to be on Java functions. So keep an eye out for that, and I'll post the new video links on Facebook, and I'll create a live for it on YouTube as well. All right, guys, have a good night.